Skipping to the skeletal system, I'm over everything to do with the cells. I don't think they're really that important. I think they're important, but I doubt I'm going to see a lot of that on the national test. So let's talk about the skeletal system. The function of the skeletal system is support of the body. It provides a rigid framework, bears weight of the body, leverage. Many muscles of the body attach to various locations on the skeletal in which they provide leverage to the attachments of the sites, and where they attach are the ligaments. Protection. Internal structures of the body are protected by the internal skeletal system, like your ribs, lungs. Storage. The matrix that gives the bones its strength is composed of calcium phosphate material. This is stored in a usable form of bone. Bones also serve as a storage system for yellow bone marrow, which stores lipids. Lipids are fats. Maintains calcium levels. Bones are a reservoir of, let's do that. Bones are, I like that better. Reservoir of calcium. When concentrations of calcium in the blood tissue is too low, parathyroid hormone stimulates the release of calcium from the bones to get into the bloodstream. Concentration of calcium is too high, hormone secreted by the thyroid gland, multiple thyroid glands, inhibits the removal of calcium from the bone. I don't know if it's multiple, I don't think it's multiple thyroids, but you do have your endocrine system. There's multiple endocrine sites. Blood cell production. The bones contain red marrow, which is responsible for making red blood cells and white blood cells and platelets. The location of red marrow or whites, or the site of blood cell production. This is called hematopoiesis. I can't say this word. Hematopoiesis. Hematopoiesis varies with age. Two distinct portions of the skeleton. You have the axial skeleton, composed of bones of the central part or the axis of the body. So this is your skull, composed of the cranium, basilar skull, face, inner ear, thoracic cage, cavity formed by the sternum and 12 pairs of ribs. The vertebral column, the spine, 33 irregular bones known as the spinal vertebrae. And then you have your appendicular skeleton. So your axial skeleton and then your appendicular skeleton. So these are my appendages. Your shoulder girdle, your pelvic girdle, and bones of the upper and lower extremities, such as arms and legs. Major structure and skeletal system bones. Cartilage, tendons, and ligaments are important connective tissues that help provide support to the framework of the skeleton. You have your articular cartilage, covers the end of the bones where they form joints. They provide cushioning and allow bones to move smoothly against each other. Tendons are specialized tough cords or bands, dense white connective tissue that connects muscles to bones. Ligaments are tough, white bands and tissues that connect bones to each other. When a muscle contracts and tendon pulls on bones, resulting in motion of the joint, where the joints, two or more bones come together, allowing movement to occur. A strain or a muscle pull occurs whenever a muscle is stretched or torn. Characteristics and compositions of bones. So classification according to their shape. You have long bones. Include humerus, ulna, radius, femur, tibia, shin bone, and fibula. So that's all of your parts of your appendicular skeleton. And then this consists a part of the body called the shaft, two ends that permit movement to the joints. Attachment of points for muscles that allow mechanical basis of movement. And then you have short bones. This includes the phalanges, make up the fingers, toes, metacarpals, bony portions of the hands, and metatarsals, the arches of the feet. Assist with fine movements in several anatomical planes and that are compact and strong. So more complex than the bulky movement of your bigger muscles. That's why you can play piano and guitar and things like that. Flat bones include sternum, ribs, scapula, and certain skull bones. So you have thin, broad bones, usually protected that encase vital organs, often are curved to help form walls and cavities. Irregular bones, so your mandible, your lower jaw, facial bones, vertebra, spine, pelvis, and these all have unique shapes and functions that are designed for a specific function. Your sesamoid bone, a type of irregular bone, includes your patella, kneecap. It's the only bone like it. Sesamoid bone develops a certain tendon to protect the tendon from excessive wear where they cross major joints. Protect your, I already forgot what it's called. Medulla? No, not medulla. I want to say metatarsals. I'm done with tonight. It's not scapula. Patella, that's what I'm trying to say, patella. Knees over toes guy on Instagram, really good about knees and, I guess if you play tennis a lot, maybe your elbows are at risk, but knees especially, take care of those. Do a lot of backwards walking movements, backwards lunges, up hills, pulling weights, anything to increase blood vessel growth and flow into your kneecap. You can't even see my knees. All of those things are going to help your joints, especially long term, because you only deteriorate. Thin, broad bones are usually protect encased vital organs and are often curved to help form walls of cavities, like your ribs. Irregular bones, these include mandible, we already talked about that. Common characteristics of each type of bone. So you have two main types of bone. You have compact bones, solid or cortical, and mostly solid with few spaces, contains a central space called marrow activity and marrow canal. Cancellous bone, spongy or trabecular. So the cancellous bone consists of a lacy network of bony rods called trabeculi. Either trabeculi or trabeculae. Trabeculae are oriented along the lines of stress to increase weight-bearing capacity of the long bone. So you have three regions of the long bone. You have the diaphysis, metaphysis, and metaphysis, and epiphysis. So obviously the epiphysis, like the epidermis, epi on the outside, metaphysis, and then diaphysis. So the diaphysis is the shaft of the long bone composed of compact bone tissue, contains specialized cells that are important in forming and repairing bones, blood vessels, and yellow bone marrow. The epiphysis at each end of the diaphysis contains the epiphyseal plate or growth plate during childhood. Metaphysis is between joining the diaphysis and the epiphysis together. Then you have the periosteum. Periosteum is a double layer of connective tissue. It lines the outer surface of the entire bone, with exception of areas covered by the articular cartilage. Contains a rich supply of blood vessels, lymphatic vessels, nerves, bones, and elastic fibers. Bone formation and growth. So bone, you have the osseous tissue. It is a type of connective tissue. Then you have the bone is composed of bone cells and matrix. Three main types of cells in the bone. You have the osteoblast. This form bone and maintains strength of existing bone. Then you have the osteoclast, breakdown and reabsorb of bone. And then you have the osteocytes, mature osteoblasts found in lacunae, these small cavities or chambers within the bony matrix. Bones begin to form in the utero at 6 weeks. Bone-forming cells, osteoblasts, develop depositing bony matrix around them. Once the matrix has surrounded the osteoblasts, they are called osteocytes. Bone develops into hyaline cartilage that is shaped similarly to the bone that it will become. Bone growth continues through the adolescence. Osteogenesis is the formation of bone. The process of placing other tissue within the bone is ossification, and the process of the bone formation is the endochondral ossification. And an ossuary is a place that you store bones from dead bodies. Intramembranous ossification is the process of the form of flat bones. Flat bones develop into connective tissue and membranes that are placed in spongy bones and compact bones. Fontanelles, the soft spot on an infant's skull, very important. That's why you don't touch, well, I mean, you can touch it, but yeah, you gotta be careful with babies. When the bones are growing, the diaphysis meets the ephysis and the epiphyseal plate. Growth depends on good nutrition and several hormones, including human growth hormone, thyroid hormone, estrogen, and testosterone. After the epiphyseal plate experiences closure, the long bones can no longer grow. Osteoblasts and osteoclast activity is balanced, so that way the bones grow with uniformity. The bone development, growth, and repair are influenced by heredity, nutrition, hormones, and exercise. Joints, articulations are formed whenever there are two long bones that come into contact. So these are your joints. Here we go. All right, so your femur, that's obvious. Patella, we know where that is. This is new. Synovium, like synovium fluid. Joint space, meniscus. All of this is right here. Articular cartilage, and then we know where the tibia is, tibia. All right, and then I guess this is, it's not nervous system. It must be like fat. And then up here is the muscles. So you have your quadricep tendon and quadricep muscles. Femur, obviously, ligaments here, capsule, so that's a muscle, patellar tendon, tibia. So it's important, like I said, to do like backwards walking motions and lunges for the sake of increasing blood flow to this area, just to make sure that they don't hurt and get things like arthritis and whatnot later. Joints consist of the end of bones that make up the joints surrounding, connecting, and supporting tissue. Joints allow movement of extremities. Proprioception is the awareness of motion and position of a body. Most joints are named for two bones that form them. For example, the sternoclavicular joint. So I know this is a sternum, I know this is a clavicle, so I guess where those go together, sternoclavicular joint, is an articulation between sternum and clavicle. Types of joints that are classified by structure. You have structural classification of a joint determined by the type of soft tissue that connects the bone to a joint to each other. So we have the fibrous, cartilaginous, and synovial. Joints are classified according to the function of synarthrosis. Immovable. Amphiarthrosis, slightly movable. Diarthrosis, freely movable. Synarthrosis, immovable. So something about that word. I'm trying to think of a word that has the same root word in it. That would be immovable. 230 joints in the human body are summarized as follows. You have fibrous joints lying within the bones that are closely in contact with each other. Fibrous joints are joined by thin, dense connective tissue, suture between flat bones, the skull, the tibia, and the fibula. No real movement takes place in most of these joints. Cartilaginous joints, also known as amphiarthrosis, these joints allow for minimal movement between the bones. Pubic symphysis and the joints connecting the ribs and the sternum are examples of this type of joint. Synovial joints, diarthrotic joints are the most mobile and complex joints of the body. Bones of a synovial joint are connected by a joint capsule which encloses joint cavity. Where's the no real movement takes place between these joints? What's an example of that? Tibia and fibia. Yeah, I guess that'd be an example. So here, this is the compact bone. This is where the bone marrow would lie. Blood vessels and nerves. Synovial space is for lubrication between the two. Articulohyaline cartilage. Tendon sheath right here. Inner layer synovial membrane. And outer layer dense connective tissue joint capsule. Yeah, spongy bone, tendon. There you go. This figure shows the joints of the body. All right. So yeah, we have several different types of joints. So between all of your spinal cord, you have planes, gliding joints. Whenever someone says they slipped a disc, that's your disc. Then you have your pivot joint, so you can turn your head. Joints between two different vertebrae. So immovable joints is the suture in the cranium whenever you look at someone's skull. Articulation of the teeth and mandible, so yeah, that's immovable as well. Ball and socket joints, so that would be connecting your, what is this, humerus to, I'm not even sure what it connects to, somewhere in your clavicle area. Slightly movable radius and ulna, just like your tibia and fibia. Well, actually, those aren't movable at all, right? It's what they said. Slightly movable articulation between vertebrae, just barely. Saddle joints, so that is movement in the right angles of the thumb. Right angles. Ellipsoidal joint, nearly hinge movement, restriction of rotation between the radius and carpals between the skull and first vertebrae, and then you have your hinge joint, so that would be like your knee. How many more of these do we got? Let's stop at 100. The joint capsule is made up of an outer layer, fibrous connective tissue, and inner synovial membrane layer. The synovial membrane secretes synovial fluid, nourishes the joint, and also removes waste products, microorganisms, and debris. Articulating bones. Articulating bones of joint are held in place by strong ligaments and add support. Synovial joints are classified by ball and socket. Condyloid, gliding, hinge, pivot, saddle joints. The bursa is a small pad-like sac or cavity that is filled with a small amount of fluid that helps reduce friction between the tendon and the bone, or between a tendon and ligament. Olecranon, bursa of the elbow, and prepatellar bursa of the knee. I probably said like all of those wrong. Axial skeleton, composed of the skull, thoracic cage, vertebral column. The brain is within the skull, and the heart, lungs, great vessels within the thorax. Spinal cord, contained within bony spinal canal. Connects the brain and skeletal muscles, skin, and other structures by means of the spinal nerves. 31 pairs of spinal nerves attach to your spinal cord and communicate with structures primarily located in the neck, trunk, and extremities. So you have C1 through 5, thoracic 12, so that is 5, 12, 17, plus another L1 through 5, or is it 7? 6, 7, I can't remember how many. I want to say 5, but I think it's more than 5. But that's 22, and then everything that's in your hips, pelvis. Skull. The skull is at the top of the axial skeleton. The skull contains, 28 bones in 3 anatomic groups. You have your ossicles, your cranial bones, and your facial bones. All right, so mandible, maxilla, that's easy. Then you have your zygoma, your nasal bone. Okay, nose is easy, orbital is easy. Frontal bone. It's in the front. Parietal bone, okay, in the back. Temporal bone, that's where your ears kind of are a little bit. Occipital bone, the very rear. External auditory meatus, that's your ear. Mastoid process, okay, so that helps for mastication, so you can chew. Temporomandibular joints. Cervical vertebrae. Thought there'd be more than that if there is 28. Okay, this figure shows components of the skull. Okay, so nasal bones, ethmoid bones, vomer, maxilla, mandible, middle inferior nasal concha, zygomatic bone, lacrimal bone, temporal bone, sphenoid bone, frontal, and then maxilla palatoid, sphenoid, vomer, occipital. And this is your foramen magnum. All right, we'll stop at 100.